Hi, my name is Gunapala Bhanuprakash. Here today I am explaining about probability distribution function in capital PDF. So let us know about what is capital PDF means probability distribution and two examples about probability distribution function and related formulas about probability distribution function. Let's start what is probability distribution function with a definition. Probability distribution function means we can denote it as capital PDF. Probability distribution function is a function that shows how probabilities are distributed over the possible values of a random variable. The probability distribution function is a function that shows how probabilities are distributed over all the random variables. The possible values of a random variable. It explains only possible values of a random variable. So next, for mathematical formula of probability distribution function. X of x is equal to P of capital X less than or equal to small x, where here capital X is a random variable where we take X, we can take anywhere. Capital X always refers to random variable. Okay, capital X refers only random variable. We know about random variable. Okay, random variable. So here small x is equal to real number. Fx of x means what is fx of x? Probability x, capital X less than or equal to small x. Probability less than or equal to small x. Okay. Here P means probability. X is random variable. Small x is real number. Fx of x is equal to probability that less than or equal to x. It is mathematically represented formula for capital PDF. Capital PDF లో మనం రిప్రజెంట్ చేసేది ఇది ఫార్ములా. ఓకే, why we use a probability distribution function? What is the purpose of use the probability distribution function? To understand the probabilistic behavior of a random variable, means the behavior of the random variable, we use the probability distribution function. Use probability distribution function. Okay. It helps to calculate cumulative probabilities. Cumulative probabilities for essential for analyzing probability in real world. In real world means the problems like tossing a coin, games, measurements. Measurements means games. Games, like Ludo or throwing a dice. Measurements means for the length of the land and everything. What's the measurements or a certain angles of some examples. Where is PDF is used in probability theory and statistics, in engineering for analysis behaviors, in data science for modeling uncertainties. So mainly we use in BTech in probability theory and statistics. So we have a subject in BTech, probability theory and statistic process. So we know about means PTSP called, we have that probability theory and stochastic process. In engineering for analysis and signal behaviors, the data science for modeling uncertainties. Okay. So how do we calculate the PDF? So how can we calculate the PDF? Cumulative probabilities of a range. For example, we can take a coin for a tossing. Means tossing means um, for a for cricket we use tossing a coin that heads or tails will occurs. So let us take a three pairs of coins or the days for calculating PDF, capital PDF, proper distribution function. We can uh, we can we can calculate that three pair tossing we can define as x is equal to number of tail shows. Means we take three coins for tossing three coins, and all the outcomes will come from the tossing a coin. The outcomes of a tossing a coin we can calculate by using capital PDF. Capital PDF. The formula for capital PDF is fx of x. Capital fx of x is equal to p of x, capital X less than or equal to small x. P of x, capital X less than or equal to small x. So now, for example, we can take three tossing a coins and toss a coins. We get three outcomes. Uh, let's show right how the outcomes will come. For the sample space, total outcomes means 2 power 3 in 3 outcomes. We will take 3 coins, 3 tossing a coins is equal to we get 8 outcomes. Means 1, 1 by 8 outcome is tails, tails, tails. We get 8 outcomes like this. Means tails, 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 tail, tail, head, tail, head, tail, head, tail, tail, head, tail, head, head, tail, and last 3 heads. X is equal to 1 is equal to 0 for the event. No coin shows tails. Means once there is no event for the event, no coin show tails. So X is equal to 1 for the event. One coin show tail means another coin show will head. For X is equal to 2 for the event, two coin shows tails. One coin will show head means this. Then the outcome is second. For x is equal x4 is equal to 3 for the event, the all coins shows tails. First outcome means that tossing the coins of tossed the coin, the outcome will whatever it will come like tails head. Next, p of x1 is equal to 1 by 8 means the only outcome is heads will come. The three coins will show heads only. It means the outcomes only shows heads. Means the outcome only shows heads. This is the probability. Next, p of x is equal to 2 means 3 by 8. The outcomes will come 2 heads, 1 tail, head, tail, head, tail, head, tail, head, head. Means the outcome will comes tail, head, or head, tail, whatever. Means three coin shows different outcomes. Three coins show different outcomes. Once heads, tails, tail, head. P of x3 is equal to 3 by 8. P of x3 is equal to 3 by 8. All 8 outcomes will comes some. T means tail, head. tail, head, tail, head, tail, tail. The outcomes will differ, and the outcomes will be different. The coin tossing also will be different. Once we tail one coin, so we see that time the coin hits. We will toss. The outcome will be tail. When the face is tail, we toss the coin. The outcome will be head. For try this for example. So P of x4 is equal to 1 by 8. Here only outcome is tails, tails, tails. Here P of x1, P of x4 is same. P of x2, x3 is different. Next, outcomes, different outcomes. These two are different. This is only outcomes, means head, 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 head. So this is the probabilities of n calculated is equal to 1 by 7. So fx of x4, here x4, here also x4. P of x1 plus x2 plus P of x3 plus P of x4 is equal to all fx of x are calculated in. So next, yes, let's do one small problem. For example, in a given n experiment, if a random variable x has elements capital X is equal to 1 comma 2 comma 3 comma 4 and 5 6, 4 comma 5 comma 6, with the probabilities here, the probabilities are given. P P P suffix capital X of x small x is equal to 2 by 36, 8 by 36, 12, 7, 5 by 36, 12, 2 by 36, 2 by 36. So we can solve by using these elements with the probabilities, we can solve a problem. And at the last, we can draw the we should draw the graph about these probabilities. So let us start our problem. Yes. So we draw the distribution function fx of x, function of capital X. Here fx of x1 is equal to p of x1, capital X greater than x1 is equal to p of x1 is equal to 2 by 36. Given probabilities are written by fx of x1 p of x greater than, this is PDF probability distribution function formula. By applying the formula, we we can solve the formula question which given. Now we solve the problem by using capital PDF, means probability distribution function. Fx of x1 is equal to p of x greater less than or equals x1 is equal to p of x is equal to 2 by 36. Given probabilities, so we can written like this uh, mm, and draw the graph by using this formula and calculating with all probabilities given by question. So we can calculate the p of x1 plus p of x2. We got 10 by 36. Here fx of x3 is equal to p of x1 plus p of x2 plus p of x3 is equal to 22 by 36. Means here 10 by 36 plus 12 by 36. Here, once here, see here. Here, P of x1, P of x2, 2 plus 8. Here we got direct step, means 10 by 36 plus 12 by 36. Here also P of x1 plus so on P of plus P of x4. Here P of x1, x2, x3 are plus we got 22 by 36. Don't confuse. We add the P of x1 plus P of x2 plus P of x3. We got 22 by 36. P of x4 is equal to 7 by 36. Overall, we get 29 by 36. Okay. Here also P of x1. So there is some logic. Here we got the 22 by 36. We will get the answer also 22 by 36. Means we add the 3. Here we got 10 by 36. Here we add P of x1 plus P of x2. We got 10 by 36. Means here 2 plus 8. We got 10 by 36. Here 22 by 36 also this one P of x1 plus P of x2 plus P of x3. We got 22 by 36. Here also P of x1 plus P of x2 plus P of x3, P of x4, we got 29 by 36. P of x1 plus x2 plus P of x3 plus P of x4, we got 29 by 36. Here P of x4, ఇక్కడ P of x4 దాకా 29 by 36 వచ్చింది మనకి. ప్లస్ P of x5. x5 ఎంత వచ్చింది 5 by 36. 5 by 36 వచ్చింది మనకి. అందుకే 34 by 36. ఈ రెండు ప్లస్ చేస్తే 34 by 36. Here P of x1 plus P of x2 plus P of x3 is equal P of x4 plus P of x5. P of x6 is equal to 2 by 36. Here P of x1, P of x2, P of x3, P of x4 plus P of x5. We got 34 by 36. Here we got 1. Means all are equal to 1. Okay. So now we all summarize it. So let know about so now we will discuss what we discussed in over this video. First we discussed about what is PDF and the definition of cap PDF and mathematical formula for the capital PDF means probability distribution function, and we solve a problem. Now we see in this here. So thank you.